So this is the cab of 4449 in the daylight. As you can see, each appliance does something very different. So we'll start with some of the big stuff. This is the throttle, obviously. This controls your speed for the locomotive. That puts power to the rail there. Then this is the event recorder up here in case of an emergency. Master speedometer right here. However, in 1941, the 4449 was once capable of 110 miles per hour.
Wow.
But today it only does about 80. Up here, whistle cord. This is a superheated steam whistle on this engine. It's a 3-chime Hancock from from another daylight locomotive called 4452, which was scrapped in 1958. And we got the whistle from 4452 off of eBay, believe it or not, and installed it on this locomotive.
Wow.
Up here, various steam pressure gauges. The biggest one that we are concerned about is this one right here. That's the master boiler pressure. That's 300 pounds per square inch, or PSI.
Wow.
Then up here is our cab signal readout control box. Then yes, we do have GPS up here. Then this small silver handle is the locomotive brake for the engine and tender only. Then right up here, I don't know why this was moved, but the sander, this is the sander control. And somebody is obviously screwed with this. Then this is the air horn valve right here. Press this down, lets air out, and starts the air horn on the front of the engine. Down here is the bell ringer. That rings the bell out on the front end of the locomotive. This is the reverser right here. Pretty much like your automobile, forward, neutral, reverse. Then the long handle here, if I didn't mention this already, this is what's called the train brake, which controls the air pressure for all of the passenger cars in the consist. Then up here is your railroad radio telephone device, and all of that communication is sent through this control box here. You punch in various buttons here. This puts in the right railroad radio frequency for the network that we operate on. This interesting box right here is the diesel control box. And so when we typically would use this most recently was 2017, when we took a trip down to Bend, Oregon. We had to have an Amtrak diesel engine in the consist behind the locomotive to provide electrical power and HVAC systems for the passenger cars in the consist. But to control the diesel, this is where that happens right here. So there's the generator starter right here, the various alarm buttons right here. This is your forward, neutral, reverse for the diesel. This is your power notch handle here. And for the diesel, there's 8 notches of power. And we always leave it in idle when we're not attached to a diesel. And then this is the emergency stop for the diesel. We only use that in case of emergencies. That's if all of a sudden the prime mover power plant shuts down, or the generator goes kaput on the diesel. So let's say all of a sudden, for some unknown reason, the diesel goes offline, and its main prime mover power plant shuts down and kicks itself offline. Then the diesel is no longer able to supply power. So this is to cut off any electrical and physical power to the diesel right here. So if the diesel goes screwy, that's to shut off power to the diesel. And up here we have some of the other various steam gauges. This big one right here is the cylinder cocks. That's off the left and right hand sides of the steam engine. That gets rid of any excess water out of the cylinders in the locomotive. This is steam line heat right up here. The smaller one is the Mars dynamo. That's for electrical power for the Mars beam headlight, which goes in a figure 8 pattern when the engine's in operation. These are master and auxiliary electrical dynamos. These are connected up to the small steam turbine up on the top of the locomotive up here. And that was original to the locomotive in 1941. But now that when we take the engine out on real big mainline trips with an Amtrak engine, we really don't need to be using the onboard steam turbine, but we always have it engaged anyway, because that powers the cab lights, for example. And so we always have these dynamos turned on, so we can make sure we have good lighting for the engine crew in here when they're running. Then up here are the water gauges and steam injectors. Then this over here is your oil manifold pressure, air pumps. This is a really critical one right here. The air pumps are out on the left and right hand sides of the locomotive. The air pumps, incredibly, are actually driven by pistons, and so they release a large amount of steam when we're operating, and they make a lot of noise. This is the feed water heater pump out on the front end of the locomotive. The feed water heater pump is putting hot water into the boiler. Then we have we have a steam heat regulator that's been removed for inspection. Then we have our steam pressure increase valve right up there. And then a couple of the other big ones. This up here is the tricock, and that is actually connected to the water sight glasses. The water sight glasses are interesting. You have to make sure there's always water filled to the top of the water sight glass, and you never want to see the water safety sight glass empty, because that means there's no water in the boiler, and that will result in kaboom! Yeah. The boiler will explode, and that traces its lineage back to the 1990s on the Gettysburg Railroad in Pennsylvania. Kind of a bit of a long story, but they bought a couple of steam engines out of Canada. Turns out those engines were not certified to be safely operated here in the U.S., and they had no crew on board certified to operate that engine. And turns out when they got the engine on the property, these water sight glasses that were on those engines were broken. The engineer went and put his finger through the broken glass, and come to find out, he felt no water in the sight glass. He's like, and apparently he turned to the other crew. He's like, "Uh-oh, there's no water. We need to shut it down." And so that meant that there was no water over